To understand the silence of the desert, we must first listen to the noise of the jungle that preceded it. Millions of years ago, before the first grain of sand claimed its territory, our planet was a captive of humidity. But Earth is not a static painting, it is a restless engine. As the great tectonic plates shifted, tearing supercontinents apart, they altered the flow of ancient oceans and the currents of the sky. The birth of a desert is not merely the absence of rain, it is a violent act of geological exclusion. It begins with the drying of the soil, the death of the root systems that anchor the earth, and the eventual triumph of entropy. What was once a canopy of life becomes a graveyard of dust, waiting for the wind to sculpt it into dunes. Why do the world's greatest deserts, the Sahara, the Arabian, the Kalahari, align so perfectly across the globe like a belt of fire? It is no accident. It is the result of the Hadley Cell, an invisible atmospheric engine fueled by the sun itself. At the equator, hot air rises, dumping its moisture as tropical rain. But what goes up must come down. This air, now stripped of its water, travels toward the poles and crashes back down at the 30th parallel. It descends as a dry, high-pressure hammer, suppressing cloud formation and baking the land beneath. These regions are not dry because the rain forgot them. They are dry because the atmosphere physically crushes the possibility of storms. Not all deserts are born of the sun. Some are born of stone. This is the rain shadow effect, a geological blockade where mountains act as gatekeepers of life. Consider the Atacama, the driest place on Earth, or the Gobi, isolated behind the Himalayas. Here, the mountains force moisture-laden winds to rise. As the air ascends, it cools and releases its burden of water on the windward slopes, creating lush forests. But by the time the air crosses the peak and descends the other side, it is bone dry. The mountain casts a shadow, not of darkness, but of drought. In these lands, it can take centuries for a single drop of rain to touch the ground. The desert is a shapeshifter. The Sahara, now an ocean of sand the size of the United States, was once the Green Sahara. Only 6,000 to 11,000 years ago, this wasteland was a network of megalakes and savannas, home to ancient human civilizations. This transformation was driven by the Milankovitch cycles, subtle wobbles in Earth's orbital axis. When the axis tilts, the monsoon rains shift northward, turning the desert green. When it tilts back, the rains retreat, and the sand reclaims its throne. This tells us a haunting truth. Deserts are not permanent scars, but sleeping giants, waiting for the planetary clock to wake them, or put them back to sleep. Today, a new force is carving deserts from the living earth: us. Desertification is the rapid degradation of land in dry areas, accelerated by climate change and human activity. We are watching the Aral Sea turn to dust and the Gobi expand its borders. But unlike the tectonic shifts or orbital wobbles of the past, this expansion is happening on a human timescale. Yet, we are also the first species with the power to halt the sand. From the Great Green Wall of Africa to regenerative agriculture, the final chapter of the desert's emergence is currently being written. Will we be buried by the dust, or will we learn to hold back the tide? The story of the desert is ultimately the story of water, and our ability to protect it.